In this video, we are going to look at multiplying rational expressions. And the process for this is going to be like any other problem in this unit. We're going to factor everything that we can, and then we're going to multiply across both top and bottom and simplify. So if we think back to when you are multiplying or when you learned how to multiply fractions. Okay, so let's think back to that. If you had a problem like 1/10 times 5/7, okay, the procedure for that was just to multiply the numerators and then multiply the denominators, and that was it. And then you could simplify if you could. Like both of these, we can divide by 5 and get 1 over, this is a 70, 1 over 14. That was the process. Now, when you got, a little bit better at this or wanted to be a little bit maybe more efficient, you learned that if there were factors like diagonally cross from each other or over each other, you could cancel some stuff out. So on this particular problem, we could say, okay, let's divide 5 by 5 and get 1 and divide the 10 by 5 and get 2, okay? And then you can multiply across the top and across the bottom and you get to 1/14 right away instead of simplifying at the end. So these are things then we're going to look for when we are multiplying more complex expressions. So I would recommend pausing the video and factoring everything you can to get that practice. And then once you've done that, go ahead and press play. Okay, so on this one, the top is just a single term. There's nothing to factor there. The bottom denominator, we want to really be looking for difference of squares because they pop up a lot. If that's something that you're having trouble seeing, in the video resources in the drive, there is a good con video that covers that. Okay, you're going to keep seeing that, so you need to have a good understanding of that to be successful. Okay, and then on this next one, I'm noticing that 10x minus 30, we can divide a 10 out of that or factor a 10 out, and then what's left is x minus 3. Distributive property in reverse, and then the denominator of this is x over 12. Okay, we're going to do this two ways. The first way is to not simplify anything ahead of time, but just multiply across the top. So we're going to multiply the 12 and the 10 together, and that gives us 120. And then we have an x to the third that we're multiplying, and we have an x minus 3 that we're multiplying. So some people, like I've heard students say, so we just put them all together. Well, we're multiplying them all, and when I list out 120 and then x to the third, I'm representing 120 times x to the third times x minus 3. So I am multiplying those. And then I'm dividing that by x plus 3. This pen is not the best. X plus 3, and then times x minus 3. So again, multiplying those, and then x to the 12th. It doesn't matter what order we multiply. Typically, if you have any single terms like x to the 12th, you put that out front, but it wouldn't have been wrong to put it back here as well. Okay, so now we're looking for things that we can cancel. So x to the third divided by x to the third is 1. So I can cross those off because, again, it's just a 1. And 1 times anything is whatever the anything is. Okay, and then I have x to the third up here. So these 3 x's are going to cancel out with 3 of these x's down here, leaving x to the 9th. Okay, if we think about that, way back maybe in 8th grade math, x to the third is x times x times x, divided by x to the 12th. There's 12 of these. 3 of these cancel out, 3 sets. They divide to 1, and there would be 9 left. That's where that 9's coming from. And then we have 120 in the numerator. That's all that's left up there. And then we have x to the 9th times the quantity x plus 3. And that would be our product on that one, our solution. Okay, now that's one way to do it, and it works just fine. The other way is before you multiply, you can look for things to cancel. And it doesn't necessarily make it easier, might make it a little bit faster. It's just another way to think about stuff. And in order to cancel things, you have to have the same top and bottom because you're dividing to get 1. So here I'm saying x minus 3 divided by x minus 3 is 1. And we can cancel those because everything is in factored form. We just have these factors being multiplied together. This wouldn't work in, like, if we had like 10 plus 7x divided by 7x. These don't cancel because we're not in factored form up top. We need to have things that are being multiplied together. All right, and then we can still look diagonally across and see, okay, these 3 x's will cancel with 3 of these, leaving x to the 9th. And now I have 12 times 10, or 120, over this times this, so x to the 9th times x plus 3. And I get the same answer. I just simplified before multiplying the top numerator and the bottom denominator.